Okay, as we said yesterday, we are going to learn graphical descriptive techniques from today, and after that, we'll discuss numerical descriptive techniques. Today, we are going to learn some simple and common types of graphical descriptive techniques. Before that, the first thing we need to know that what types of data are there. Okay, first of all, the first type of data is called interval data, or in Chinese, we call it 定量数据. Okay, what is interval data? Interval data has a number, and the number really means something. For example, heights, weights, prices are all interval data. Sometimes we say that interval data is also quantitative data or numerical data. These are the same. Okay. For example, we for a set of test marks, test marks has numbers, and these numbers really mean something. That means your real marks for the test. So the test marks are also interval data. You should note that arithmetic operations are applicable to interval data. For example, we can use addition, subtraction, multiplication, and division to interval data. Understand? Okay. The other type of data is called qualitative data, or in Chinese, 定性数据，只有性质，它的数量不是很重要的数据啊，就有可能没有数量，只有性质的数据。Okay. Qualitative data includes nominal data and ordinal data, of which nominal data has order, but ordinal data has no order. Okay. For example, let's have a look at the nominal data first. The values of the nominal data are categories. For example, responses to questions about marital status coded as single as 1, married as 2, divorced as 3, widowed as 4. Here we have 1, 2, 3, 4, 4 numbers, right? But the numbers here doesn't mean anything. These are just code representing the marital status. So these data are categorical in nature. Arithmetic operations don't make any sense. For example, if we use 2 to represent a number, widowed divided by 2 is not married, right? Because 1, 2, 3, 4 here are just codes. They don't have real meaning. Okay. Nominal data are also called qualitative or categorical data. So these three names are the same: nominal, qualitative, or categorical. Okay, another example is color. For example, for the color red, green, and blue, these are also nominal data because on one hand, there is no number in there. On the other hand, they have no order, right? You can't see red is greater than green. So they are nominal data. Understand? Okay. The other type of qualitative data is called ordinal data. Ordinal data appears to be categorical in nature, but their values have an order, a ranking to them. Okay, what does that mean? Okay, I'll set you an example. For example, in the college course rating system, if we denote poor as 1, fair as 2, good as 3, very good as 4, excellent as 5, these are ordinal data because, first of all, these are codes, they're numbers, right? Numbers doesn't mean anything, but they have order. 5 is always greater than 4 because excellent is better than very good. 4 is greater than 3 because very good is better than good, right? They have a rank. Well, it's still not meaningful to do any arithmetic on this data. We cannot use addition, subtraction, multiplication, or division on this data, but we can use sorting, right? We can sort this data. So they are called ordinal data. That is, order is maintained no matter what numeric values are assigned to each category. Okay. Another example would be your test grade. For example, we have A, B, C, D, F to represent your test grade. These are also, okay, first of all, they are nominal data, right? Because there's no numbers there. And then they are also ordinal data because there is order. A is always greater than B, B is always greater than C, C is better than D, and D is better than F, right? There is an order there. We can sort this data. So these data are called ordinal data. Okay. In summary, types of data. How many types there? Okay, generally speaking, there are two types, right? First type is called quantitative data or interval data, right? Interval or quantitative or numerical. Okay, this is the first category. Second category is called qualitative data. Okay, you should note that these two words are very similar. Do not mix them together, right? These are different. And for qualitative data, there are two subtypes. First type is called nominal data. Nominal data has order. Oh, sorry, this nominal has no order. And ordinal data has order, right? Okay, any questions? If there's a typo on the lecture slides, please correct it by yourself if you already downloaded it, okay? All right, then let's have a look at the common types of charts. Today we are going to introduce only the very simple ones. Tomorrow we'll have a look at the histogram or algebra diagram, which are more complex. Okay, for different types of data, we have different types of charts or diagrams to describe them. And also for if you have a single set of data, or it depends on what you want to achieve. If you want to describe a single set of data, we have some corresponding diagrams. And if you want to describe the relationship between two variables, there are some appropriate diagrams to do this. So let's have a look at these diagrams one by one. Okay, the first one is called dot plot, or in Chinese we call it 点图. Dot plot is used to describe one-dimensional data. Okay, I'll set you an example here. Okay, for example, the following sample data sorted in ascending order is a temperature of some location. We can draw the dot plot as follows to illustrate the shape of the distribution. Okay, how to draw diagram here? I'll show you how to do this. First of all, we draw a number axis. Okay, suppose this is a real number axis. And along the axis, we check these data one by one. Okay, if, for example, if we have a -12 here, okay, we draw a circle on the number axis. For any data we find, we draw a circle on the number axis. The next one is 8. We suppose here is 8, and we found an 8, and we draw a circle here. Okay, next, we found a 10. Then we draw a circle here. Next, 13. Okay, we draw a circle here. Next, we found a 15, and we draw a circle here. Next, we found an 18. So we draw another circle. Next is 19. And we draw a circle here. Okay, in the same way, when we find a 20, we draw a circle here. 21, draw a circle here. 22, draw a circle here. Okay, 26. Okay, suppose 26 is here. Okay, how many 26? 1, 2, 3, 4, right? We find 4 26. So you need to draw 4 circles here. Okay, 27, 1, 2. 2 27s. So we need to draw 2 circles here. 28, 1, 2, 3. We have 3 28. Okay, this is 28. So we need to draw 3 circles here. Okay, 35, 1, 2. We have 2 35. Okay, suppose 35 is here. So we need to draw 2 circles here. And 36, 1, 2. 2 36. Then we need to draw 2 circles here. Okay, 38, only 1. So 1 circle is drawn here. And 60, suppose 60 is here. We only have 160. So we need to draw 1 circle here. Okay, in this way, this diagram is called dot plot. And in the dot plot, you can see a very rough distribution of the data, which is like this way, right? Shows that most of the data are concentrated around 26 to 28, right? This is roughly illustrating the distribution of the one-dimensional data. Understand? You should be able to draw and read such a diagram. All right, any questions? No? Okay, let's see the other example. Okay, same sample, which is the temperature of a certain location. The second diagram can be used to illustrate the distribution is called steam on leaf display. Okay, in the steam on leaf display, we use a vertical line to separate the steam and leaves. On the left-hand side is called the steam. Steam always has a unit. Okay, suppose we can use a unit of 10 in the steam here. And then we can draw the steam and leaves separately. Okay, for the first data, we have -12, right? So on the steam, we can write -1. And on the leaf, we can write a 2, which means -1 plus 10 -1 times 10 plus 2, which is -12, right? Okay, next one is 8. So on the steam, we write a 0 first. And on the leaves side, we write an 8, which means 0 times the steam unit, 10, plus leaf, which is 8, which is this data, right? Okay, next one, 10. 10 has a steam unit 1, so we put 1 here. And for 10, we only have 1 10, so we put 0 here. Next, we have 13. 13 has a steam unit of 1 and a leaf of 3, so we put a 3 here. Okay. Next one is 15, so we put a 5 here. Next is 18, 1 8, right? So 1 as steam, 8 as the leaf. We put an 8 here. Next is 19, 1 as a steam, 9 as a leaf. So we have 9 on the leaf side. Okay, and next we have 20. So we put a 2 on the steam side and 0 on the leaf side. And following the same way, when we read the data 21, we put 1 here on the row that represents the steam unit 2. And then we have 22, so we put a 2 here. Then we have 426, right? So we should put 4 6 here. Okay, first one, second one, third one, and fourth one. We have 4 6 on the leaf side on this row. And then we have 227. So we put 2 7s here. Right? Next we have 1 2 3 328. So we put 3 8 on this row. Okay, that's in this way we complete the row that starting with a 2. Okay, next we consider these data that starts with 3. Okay, first one is 35. We have 235, so put 2 5s in this row here. And then we have 236, so put 2 6 here. Next we have 138, so put 1 8 here. Okay. Okay, for the last data, 60, starting with a 6, so put a 6 here. And put a 0 on the leaf side. Okay, this is how we draw the steam and leaf display. And this diagram also roughly displays the distribution of the one-dimensional data, which is like this way, right? So as you can see here, most of the data are concentrated to 10 to 38, right? It's a very rough distribution display of the one-dimensional data. Understand? And now you should be able to read and draw the stem and display and leaf display. Okay, any questions? Okay, if you have no questions, we'll take a 10 minutes break and proceed our lessons in 10 minutes. Okay, let's take a break. All right, welcome back. Let's continue our lessons. Okay, next simple chart is called bar chart. I call it simple because you have already tried to draw this chart in our previous lessons, right? So here we use a simple example to illustrate how to read and draw this type of chart. Okay, for example, study the following problem by sampling. Last week, were you working full-time, part-time, going to school, keeping house, or what? We ask a few number of people and record their responses on a piece of paper. The responses were 1. Working full-time, 2. Working part-time, 3. Temporarily not working, 4. Unemployed, laid off, 5. Retired, 6. School, 7. Keeping house, and 8. Other. The responses were recorded using the codes 1, 2, 3, 4, 5, 6, 7, and 8, respectively. And then we list all the sampling results in the table. The first column is their work status. The second column is the corresponding code that we use to represent this work status. The third column is frequency. That means how many people responses with this status. The last column is called relative frequency, which is the percentage of each work status. The sum of the relative frequency is, as you can imagine, 100%, right? And the total number of frequency is the total number of people in your sample. Okay, and then we can use the frequency or the relative frequency to build the bar chart. Okay, again, we use a two-dimensional coordinates. The x-axis is our work status, which is the code, right? If we use frequency, for example, frequency as the y-axis, okay? The first category we have 9, 12, right? And we put a 1 here. That means for the work status coded as 1, we have 112 frequency. Okay, next, we have 226. This is coded as 2. Next, we have 40, code 3. Next, we have 104, which is code 4. Next, we have 357, code 5. Next, we have 70, and then 210, and then 54. So this is called bar chart, which illustrates the distribution of the frequency across all the work status. Okay, as you can see here, this chart is more clear, is clearer for you. Okay, the x-axis is our work status. We use number 1 to 8 to represent each status, and the y-axis is called frequency. That means in each group, how many people are there. Okay, and then this diagram illustrates the distribution of the frequency. As you can see here, most of the people chooses response 1. Okay, second largest group is response 5 here, and third largest is group 7. These these three groups have more people, right? This is called bar chart. Now you should be able to read and draw the bar chart. Okay, any questions? Okay, then I'll illustrate how you can draw this from your computer, okay? If you have internet connection, I strongly recommend to use Google Sheet. Just open your browser. You can do this following my instruction, okay? Open your browser, either Edge, Google Chrome, or Internet Explorer. Any web browser is okay. And in the search bar, type in Google Sheets. And then go to Google Sheets. If you do not have internet connection, you can use Excel or WSP. Both of them can do the same thing. Okay, I'll make it larger. Okay, first of all, we need to have this table, right? Because all of the diagrams are built based on the data tables. Okay, so let's build a table first. Okay, first column, as we just did, is called work status. And next column is code. Next is frequency. Next is relative frequency. Okay. Then we put data here. First is working full-time. Next, working part-time. Next one, not working. Temporarily not working. Okay, I'll use abbreviations here. Next one, laid off. Next one, retired. Next one, going to school. Next one, keeping house. And last one is others. And we use code 1, 2, 3, 4, 5, 6, 7, 8, right? To represent each category. Yeah, the frequencies are 9, 12, 2, 2, 6, 40, 1, 0, 4, 3, 5, 7, 70, 210, 54. Okay, relative frequency. You can calculate this out automatically. First, let's calculate the sum of this number. Okay, it's called sum. And relative frequency is achieved by each frequency divided by the total number. Okay, and we can shrink the number of decimals here. We only need 3 decimals. Okay. Okay. Sum of all relative frequencies, as you can see, is always 1. Okay. I'll give you some time to complete this table first, and then we use this table to draw our bar chart. Okay. I'll give you 5 minutes to complete this table. You can use Google Sheets or WSP in your local machine, or Excel in your local machine. If you have any questions or problems, just let me know, okay? I'll explain how you can do this, okay? Do not leave any questions, because in your final project you are do the same thing. You must be able to draw the diagram. Okay, have you finished? All right, if you have finished, we can now draw the bar chart. Okay, first of all, select the two columns that you want to create bar chart, and click Insert, and then click Chart here. Then usually the system will automatically create a bar chart for you. Sometimes the bar chart is not correct. So let's first check if the bar chart is correct. Okay. Apparently, the bar chart here isn't correct because we have two bar charts here. So we need to make some modification. Okay. First, we delete this row. So now the bar chart seems correct now, but it has not any x-axis. Then we can click on the right-hand side, add x-axis, and then select the data that corresponding to our x-axis. Click OK. And then we now can see that the x-axis is added to the bar chart, right? And then you can also make some modification using the right panel. For example, if we want to add a label to the x-axis, just click Customize, Horizontal Axis, and click Customize, and under the label called Chart and Axis Titles, click Horizontal Axis Title, and then you can put a title here. For example, the horizontal axis is our work status, so just put work status here. And then you can see the label is illustrated here, right? Also, if you want to put a label to the vertical axis, just choose vertical axis title here. And then input our label for the vertical axis, which is frequency. See, now the frequency is the label of our vertical axis. And then this diagram is made clearer, right? Okay, so next important thing is you can actually put the data labels onto each bar to make the bar clearer. So how to do this? One of the way is to choose. Okay, again, double click the diagram on the right-hand panel. Select Customize. And then select Series. And click, make sure you tick the data labels. And then you can see the labels is displayed onto each bar, right? If you want to make the labels displayed out of the bar, you can choose position. Click position and click outside end. And then now each data label is displayed outside the bar now, right? So in this way, you can make this bar chart more clearer to the readers. Okay? Understand? Okay, I'll leave you 5 minutes to finish this chart, okay? And this time, try it by yourself, but use the relative frequency as your vertical axis, okay? As you can see here, here we use a frequency. You can try it yourself to use the relative frequency as your vertical axis to see if you can draw the diagram, okay? I'll leave you 5 minutes to do this. If you have any questions, please let me know now, okay? Okay, have you finished? All right, I'll show you how to do this. Okay, let's start from the very beginning. This time, we'll use relative frequency to illustrate how we can create the bar chart. Okay, first, select all the relative frequencies and insert chart. And usually the system will automatically create the bar chart for you. Okay, this time we have the right diagram here, which the vertical axis is relative frequency. And now we can put a label for our horizontal axis. Okay, select customize chart and axis titles, horizontal axis titles, and then put work status. Then you can see work status is shown on the horizontal axis here. Okay, next, double click the diagram and put a data label on each bar chart. Okay, click customize series and show data labels. And position is outside and. Then you can see the data labels are shown on each bar. Okay. And here we use relative frequency to complete the bar chart here. Any questions? Okay, any questions? Okay, let's go on. Of course, we can also use pie chart to illustrate the same table, all right? Okay, for example, here you can use a pie chart. Different section represents different work status. Okay, also, I'll show you how to do this in the Google Sheets. Okay, for example, we use same data tables here, and then this time we'll use a pie chart. Okay, again, select all the relative frequencies and click Insert Chart. Okay, usually the system will automatically create a chart for you. If you want to change the type of chart, click chart types on the right-hand side and select pie chart from the suggested charts, or can manually select pie chart here. Right? As you can see here, this is a pie chart illustrating the relative frequency of each work status. Okay, if you want to change anything, just click Customize. On the right-hand side. All right. Okay, try to do it yourself. I'll give you 5 minutes to play with this. And if you have any questions, please let me know, okay? Okay, have you finished? Any questions? No? Okay, let's see the last diagram we are going to learn today. Okay, last question is, if we want to find the relationships of two variables, we can use cross-classification table and the corresponding bar charts. Okay, I'll use an example to illustrate what this means. Okay, suppose we have a sample of newspaper readers who are asked to report which newspaper they read. There are 4 types of newspapers there. First one is called Globe and Mail. Second one is called Post. Third one called Star, and fourth one called Sun. And we use 1, 2, 3, 4 to code these 4 newspapers. And the readers are divided into 3 categories, namely blue-collar workers, represented by 1, white-collar workers, represented by 2, professionals, represented by 3. And then the sampling result is many rows. Each row represents the reader's occupation and the types of newspaper. And here we have 354 rows. That means in the sample, we have 354 readers, right? And now question is, we want to ask if the 2 nominal variables are related. That means if the occupation of the reader and the type of the newspaper is related or not. Okay, the method is, if the 2 variables are unrelated, the patterns exhibited in the bar charts should be approximately the same, right? If some relationship exists, then some bar chart will differ from the others. Okay, so to solve this question, first we draw the cross-classification table here as follows. Okay, first row here represents all the newspapers, and first columns represents all the 3 occupations, and we put the frequencies of each category into the table. All right, and for each row, for example, the 120 here is the total number of blue collars, and 108 here is the total number of white collars, and 126 here is the total number of professionals. Similarly, on the last row, 89 here is the total number of the people who read Globe and Mail. 112 here is the total number of readers who read Post. And 81 means total number of readers who read Star. And 72 means total number of readers who read Sun. Right? And then we can draw the 3 bar charts on the same diagram. For example, for a blue collar, we can draw all the bars representing the frequency of each type of newspaper. And we can do the same thing to white collar readers and professional readers, right? Then from the diagram, we can see that the patterns of the white collar and professional are almost the same, right? And these blue collars pattern is different with white collar or professionals. That means the reading habit of the white collar workers is similar to the reading habit of the professional readers, right? And the reading habit of blue collar workers is different from the other 2. Understand? Any questions? Okay, So last, we can make the conclusion. The graphs tells us the same story as the table. The shapes of the bar charts for occupation 2 and 3, which are white collar and professional, are very similar. Both differ considerably from the bar chart for occupation 1, which is blue collar. Therefore, some relationship exists between occupation and the newspapers you read. Okay. All right. These are the simple diagrams we learned today. For the rest of the time today, I'll leave it to you to complete today's homework. Okay. If you have any questions, please let me know now. Okay. You can start doing your homework for today.